Welcome to the debate. Imagine this. It's 3 a.m., your pager's just going off constantly,
The absolute worst sound in the world for an engineer.
right? And your company's core data pipeline just failed. Why? Because an AI autocomplete tool flawlessly updated a single SQL file, but it was, completely blind to the 30 downstream reporting dashboards it just broke by renaming a crucial column.
Yeah, it is a visceral, often painful reality of data engineering today. It's a total nightmare scenario, and it is happening every single day.
Exactly.
We really crave simplicity in technology. We have this seductive idea that progress always looks like consolidation. Think about the smartphone, the camera, the GPS, the music player. They all just collapse into a single pane of glass.
Sure, the convergence theory.
Right. Because when the work gets highly complex, we desperately want that unified environment. The human brain can only hold so much context at once.
I hear that. But when you step into the actual trenches of data engineering right now, we aren't looking at a single smartphone. We're looking at a highly fragmented, intensely specialized workshop.
Very fragmented.
And that tension is exactly what brings us to the core of our discussion today. We are examining the current landscape of AI coding tools for data engineers, and we're grounding our conversation in Samuel Williams's February 2026 article from datapro.news, the AI coding tool horse race.
Yeah, an excellent piece. It details how the tool ecosystem has just completely fragmented over the past 3 months, which raises a fascinating central question for us.
Right. Is the most effective strategy for a data team to adopt a diverse stable of highly specialized AI tools, or does this fragmentation create systemic inefficiencies that demand consolidation around a unified AI-first environment?
It's the big question right now.
It is. Now, looking at this landscape, honestly, I see a beautifully specialized workshop. I will be advocating for the stable approach. I think it's exactly what we need. The distinct philosophies, the architectures, the scopes of these different tools, they make them uniquely suited to entirely different stages of the data engineering lifecycle.
You see a specialized workshop, but I look at the exact same landscape and I just see exhausting chaos.
Chaos?
Exhausting chaos. I'll be taking the dissenting view today. Juggling a fragmented array of niche AI tools creates artificial boundaries. It creates massive context silos. Data engineering is fundamentally about the flow of information across systems. So teams need to reject this tool juggling act and migrate toward an integrated AI-first environment that actually holds the entire project context in view.
Well, to set the baseline here, the text outlines a 2026 AI landscape that is divided into 4 distinct categories, plus a critical platform native layer.
Right. The 5 buckets.
Exactly. You have enterprise productivity tools like GitHub Copilot. You have agentic terminal-first tools, which are really led by Claude Code. You have cloud-native specialists like Amazon Q Developer. And finally, you have AI-first IDE environments like Cursor. The article argues that judging these tools against a single benchmark is a flawed premise. It uses this great analogy. Comparing them is like comparing a Formula One car to a heavy-duty cargo ship.
Which is a fun visual.
Right, because they all have engines, but you wouldn't enter a cargo ship in the Monaco Grand Prix. You match the tool to the job. That's true acceleration.
I come at it from a different way. The vehicle analogy is clever, but it severely obscures the operational reality of writing code. I mean, specialization sounds optimal in theory, right? Who wouldn't want the perfect micro tool for every specific microtask?
Every engineer I know.
But adopting a stable of 5 different AI paradigms means your AI literally cannot see across its own boundaries. The limitations exposed in the text are glaring.
They have scopes. I wouldn't call them limitations.
They're limitations. To'Ili is blind beyond single files. Amazon Q is a walled garden, useless outside of its ecosystem. Snowflake Cortex is restricted entirely to the data platform.
But that's where the data lives.
Sure, but the true path forward isn't managing this exhausting stable of horses. It is migrating to an environment that natively understands your code base from end to end.
Look, if you're listening to this and thinking, well, I just use Copilot and I'm perfectly fine, you have to ask yourself what scope of work you're actually doing. Let's start exactly where data engineers spend the vast majority of their time.
Daily pipeline development.
Exactly.
Daily pipeline development. Copilot is rightfully crowned by the text as the workhorse of the industry. It sits natively inside VS Code, and the sheer scale of its context engine is just staggering.
It is huge. I'll give you that.
It uses the Blackbird search engine to index 45 million repositories.
Wow.
Right? 45 million. And it uses that to deliver contextually relevant completions in milliseconds. Enterprise pilots are reporting 78% active usage, and crucially, roughly 10 hours saved per developer per week.
10 hours saved locally, sure. But at what cost to the broader system architecture?
Well, the cost is managed by its incredible multimodal flexibility. A data engineer today isn't just writing an isolated script. They live in a polyglot reality.
That's true. It's never just one language anymore.
Right. You have SQL open in one tab for your DBT transformations. You have Python scripting your Airflow DAGs in another tab, and those are the actual blueprints that dictate exactly what order your data pipelines run in.
Mm-hmm.
And then you have Terraform defining your actual infrastructure as code in a third tab. Copilot allows engineers to switch seamlessly between GPT-4o for incredibly fast line-level autocompletes and Claude Sonnet for heavier reasoning. It accelerates the exact kind of file-level daily velocity that keeps an enterprise moving.
I'm sorry, but I just don't buy that. Let me tell you why.
Okay, go ahead.
You just hit on the exact phrase that reveals the fatal flaw in the stable approach: file level. Copilot operates primarily at the file level. For a traditional software engineer, maybe building a highly isolated front-end web component, maybe file-level awareness is enough.
It's usually plenty for front-end work.
But for a data engineer, file-level awareness is inherently dangerous. Think about the mechanics of our work. Let's go back to that 3 a.m. PagerDuty nightmare you started with.
The column rename.
Yes. Suppose you use Copilot to do something as simple as renaming a customer ID column in a foundational DBT model.
Which is a very common daily task.
Right. It happens all the time. But what actually happens next? In a data warehouse, that single column rename cascades through 30 downstream dependencies across 3 different repositories.
It ripples out.
Exactly. It impacts intermediate data transformations, it alters aggregate reporting tables, and it feeds directly into executive dashboards. A tool that is blind to those cross-repository dependencies will happily autocomplete your single file perfectly while silently breaking the rest of the pipeline.
Well,
And this reinforces the absolute necessity of a unified system like Cursor. Cursor is not a plugin. It is an AI-first IDE rebuilt from the ground up.
right, it's a fork of VS Code.
Yes, and its plan mode doesn't just guess the next line of code. It maps out implementation strategies with real-time architectural awareness. It actually sees the directed acyclic graph, the DAG, of your dependencies. Copilot is running fast, yes, but it is sprinting with blinders on.
But see, when that column rename breaks 30 files, Copilot is useless. I completely agree with you there.
Oh, you agree?
Of course. The engineer is suddenly forced to leave the IDE and open their terminal to run massive multi-file search and replace scripts to fix the dependencies. But that friction, that exact moment of failure, is exactly why the stable exists.
I don't follow.
You don't use the workhorse for deep structural changes. When you need to understand how a column rename cascades, you put Copilot away and you bring out the specialist. That is where the text introduces the terminal first agent Claude Code.
Ah, the tool running directly in the command line.
Exactly. Claude Code occupies a fundamentally different niche. It runs directly in your terminal with full file system access. It's powered by Claude 4.5 and 4.6 Opus, which, as the text notes, currently lead the SWE Bench leaderboard at over 80% accuracy for resolving real-world GitHub issues.
Over 80% is an impressive metric.
It is. And this tool is not trying to autocomplete your current line. It is designed to understand your entire project and execute multi-step changes autonomously. Let's say you need to do back-of-house work, like standardizing the YAML configuration files across 80 different DBT models.
Or executing a complex database migration script.
Precisely. Claude Code handles that structural cross-file work that a file-level tool just can't even perceive.
And how exactly does it rewrite 80 files across a massive repository without hallucinating variables or making wild assumptions about the file structure?
Well, it uses a highly sophisticated architecture called agent teams. Rather than relying on one massive AI model to do everything, senior engineers are deploying a pattern where multiple specialized agents collaborate.
Oh, like breaking down the labor?
Think of it like a construction site. You have a lightweight researcher agent powered by the incredibly fast Haiku model. Its only job is to act as a hyperactive scout. It rapidly reads through hundreds of documentation pages, maps out the dependencies, and verifies variables.
Just reading, no writing?
Exactly. It then hands a verified, hallucination-free blueprint to the builder agent, powered by the heavier Opus model. And that one actually executes the code changes. By separating the reading from the writing, you drastically reduce the chance of the AI hallucinating a non-existent dependency. It is a specialized orchestration that a single unified IDE simply isn't designed to replicate with the same level of terminal native autonomy.
That's a compelling argument, but have you considered the massive operational friction this introduces to the human engineer?
Friction how?
Well, Claude's code is powerful, yes, but it runs on a read-only by default architecture. Because it lives in the terminal and can touch anything, the agent must request explicit human approval for every single file edit, every shell command, and every network call.
I'll concede that having your terminal constantly beg for permission to run a basic ls command to list directory files can feel, incredibly annoying.
Annoying is an understatement. Think about the psychological cost here. We talk endlessly in engineering about achieving a flow state. You know, that deep, uninterrupted focus where you hold the entire logic puzzle in your head.
Right, the zone.
How can a data team possibly achieve a flow state when they are constantly interrupted by their terminal asking for permission to execute a basic shell script?
You are asking the engineer to step out of the logic of the code and become a full-time babysitter for an autonomous agent.
It's oversight, not babysitting.
The financial token costs of running these massive Opus models are high enough, but the cognitive overhead of constantly context switching between writing code in your IDE and approving prompts in your terminal is even higher. That's an interesting point, though I would frame it differently, because you are evaluating friction as a purely negative metric.
Because it stops work.
In the context of large-scale, multi-file enterprise refactoring, friction is not a bug. It is a vital governance feature.
A feature.
Yes, we're talking about an AI agent with full command line access, capable of executing database migrations that could drop production tables or standardizing entire repositories. If that system operated without a read-only by default permission boundary, it would be a catastrophic security risk.
So you're saying the interruption is the safety net?
I am saying the interruption is the only reason enterprise security teams will actually approve its deployment in a production environment.
I suppose security teams do love a bottleneck.
When a machine is rewriting 30 critical infrastructure files at once, the human engineer shouldn't be in a flow state of blindly writing code. They should be in an evaluative state, acting as the final gatekeeper for structural integrity. The tool deliberately dictates the posture of the engineer.
Okay.
That is why the stable is so powerful. Copilot gives you the frictionless flow state for daily tasks. Claude Code gives you the governed, heavily supervised scale for structural changes.
But you are still asking the engineer to mentally context switch between the IDE and the terminal, adjusting to entirely different AI paradigms. And this gets even more fractured and, frankly, more dangerous when we move beyond the local repository and talk about where the code actually runs.
You are talking about live cloud infrastructure and live data platforms.
Precisely. Because data engineering code doesn't exist in a vacuum. It interacts with real cloud resources, real permissions, and raw data. And this is where the stable approach truly begins to look like a disparate collection of walled gardens.
I would strongly disagree with the term walled garden here. I would call them highly specialized platform tools. And they exist because local IDEs simply lack environmental awareness.
Lack of awareness of the cloud, you mean?
Exactly. Let's examine Amazon Q Developer. The text notes that this tool barely gets mentioned in the broader AI coding conversation, which is a massive oversight. Copilot knows your local code and Claude knows your local project files, but Amazon Q knows your live cloud.
Only if you are firmly locked into AWS.
Which a massive percentage of enterprises are. Let me give you an analogy to explain why this matters. Copilot knows how to build a mathematically perfect door based on a file, but Amazon Q is the building inspector standing on the actual live job site, looking at the structural blueprint saying, you can't put that door there, there's a load-bearing wall.
Okay, that's a fair analogy.
It integrates directly with the AWS console. When you are writing Terraform to spin up an S3 bucket, Amazon Q has real-time visibility into your actual identity and access management, your IAM policies. It knows your live account limits.
Things an IDE can't see natively.
Right, a general IDE cannot simulate that live environmental telemetry. The source points out that Amazon Q performs automated security scans that have identified over 12,600 vulnerabilities in documented case studies.
12,600?
Yes, specifically catching things like overly permissive roles that could accidentally expose private data to the public internet.
I understand the theoretical value of live cloud context, but look at the severe fragility of these platform-bound tools in practice. Amazon Q is purpose-built for the AWS ecosystem. The moment an enterprise strategy shifts to a hybrid cloud or a multi-cloud setup,
Which is tricky, yes.
say running workloads across both AWS and Google Cloud, which is incredibly common today, Amazon Q's value drops sharply. It is a specialist that refuses to learn a new track. And we see the exact same fragility on the data side with Snowflake Cortex Code.
Snowflake Cortex Code and tools utilizing the dbt MCP server are solving a problem that neither Cursor, nor Copilot, nor Claude can safely touch. And that is live data context.
Well, they touch it, just not well.
They don't have the context. A repository-level AI might know your SQL syntax perfectly, but Cortex understands your actual live data catalog. Let's explain why that is critical. If you ask an AI to write a query to calculate monthly recurring revenue, and it doesn't know your actual data schema, it will hallucinate a column name.
It happens constantly.
Worse, if it doesn't understand your RBAC, your role-based access control, it might try to query personally identifiable information that the engineer running the prompt isn't legally allowed to see.
A massive compliance violation.
Exactly. Cortex explores raw source data and infers relationships strictly governed by those live RBAC permissions, and the dbt MCP, the Model Context Protocol, gives these AI agents safe, structured access to those trust signals before they ever generate a line of SQL.
I don't deny that live data lineage and strict RBC governance are critical. You have to prevent ungoverned AI from hallucinating metrics or violating privacy. But look at the rigid boundaries you are defending.
They aren't rigid, they're specialized.
They are rigid. Cortex can perfectly scaffold your dbt models inside Snowflake, but it cannot touch your AWS infrastructure. Amazon Q can secure your infrastructure, but it doesn't understand your dbt lineage. Copilot can write your Python scripts, but it doesn't know your cloud limits.
Right.
Adopting this stable means forcing engineers to endure significant change management simply to navigate between highly siloed tools that fundamentally refuse to talk to each other. You aren't building a seamless data pipeline. You are creating a fractured workflow where the human engineer is the only API connecting these disparate AI models.
But that is exactly the job of the senior engineer. The human is the orchestrator of the workshop. You are assuming that Cursor, as a unified AI-first IDE, can magically replace the deep proprietary integration of Snowflake Cortex or Amazon Q.
It's getting closer.
But Cursor, for all its brilliant project-level awareness and DAG mapping, is fundamentally still an editor. It reads files. It does not have native live integration with your AWS IAM policies or your live Snowflake data catalog. It generates code based on patterns it sees in your repository, not based on live environmental telemetry.
For now.
For now.
But the trajectory of the technology is clear. The reason Cursor requires a full IDE migration, which the text rightly points out is a massive change management exercise for enterprise organizations, is precisely because it is building the foundational architecture for that unified context.
It is a massive migration.
Yes, I'll admit, the data engineers truly accelerating their work in 2026 are currently running a stable. They are deploying Copilot for daily velocity, Claude Code for heavy structural reasoning, and Cortex for live data context.
Thank you.
But treating this fragmented horse race as the permanent state of data engineering obscures the ultimate goal. The extreme friction of switching tools, managing different token costs, and navigating completely disparate permission boundaries strongly suggests that a holistic AI-first architecture will eventually render the stable obsolete.
This fragmentation is a symptom of a messy transition period, not the final destination.
This has been a deeply illuminating exchange. If we pull back and look at what we've unpacked today, my position remains that the current fragmentation is actually a profound strength.
I know you stand by your stable.
I do. The specific capabilities of Copilot for frictionless daily velocity, Claude Code for governed autonomous refactoring, and platform-native tools for live contextual awareness provide a robust toolkit. The stable allows engineers to deploy the right mechanism for the right scope of work without compromising enterprise security or system stability.
And my summary is that while these individual mechanisms are technically impressive, their rigid boundaries create unacceptable context silos.
The silos again.
Yes, the file-level blindness of Copilot that causes those cascading failures and the walled garden fragility of Amazon Q highlight the urgent need for a unified system. Cursor's project-level awareness points toward a near future where contextual awareness is holistic, ultimately reducing the massive cognitive load and change management fatigue currently burdening our data teams.
Yet, despite our disagreement on the optimal path forward, I think we both clearly acknowledge a profound shared convergence here. The maturation of these AI tools is forcing an absolute architectural revolution in how engineers work.
Absolutely. Whether an engineering manager decides to curate a highly specialized stable of diverse tools or undertakes the massive operational effort required to migrate their entire team to a unified IDE like Cursor, the fundamental nature of the job has irrevocably changed.
It has. The days of simply writing code in a static text editor and hoping it runs in production are permanently over.
They truly are. The AI is no longer just a fancy syntax checker. It is an active, opinionated participant in the engineering lifecycle. Which brings us back to where we started.
The workshop versus the factory floor. Exactly. If you walk into a professional engineering workshop, you have to decide what kind of operation you're running. Are you building a highly flexible garage where every specialized wrench, researcher agent, and diagnostic machine is available for the human mechanic to orchestrate?
Or are you trying to build a fully integrated, automated factory floor where the environment itself holds the master blueprint?
It is a systemic question every data team will have to answer for themselves as they honestly evaluate their own dependencies, their security postures, and their daily workflows.
There's no escaping the choice, really.
Exactly. I suggest our listeners explore their own workflows tomorrow morning, look closely at where your blind spots actually are, where your context drops off, and where you experience the most friction. The source material offers a fascinating map of the territory, but how you navigate it is entirely up to you. Thank you for joining us on The Debate.